Right, let's just read that again for me, please, Abdullah.
The graph of y equals f of x is shown on the grid. On the grid above, sketch the graph of y equals minus f of x.
So which is the bit that they modified? Which is the bit?
The minus.
The minus is the minus outside the function or inside the function?
Outside.
So outside the function, does it mean it's in the reflection in the x-axis or in the y-axis?
Is it the y-axis?
So it's a reflection in the x-axis. Okay, remember, if it's minus on the outside, that's the normal place that you find it more common. If they put the minus on the inside, then it's in the y-axis, okay?
Yep.
Remember that way around. Okay, so we're going to reflect it in the x-axis. So let's get a highlighter and indicate which way our mirror line is. So it's not the most straightest line, but that is the mirror. The mirror is the x-axis, mirror line. So everything which is above has to go where now, Abdullah?
Underneath.
So what happens to the point that's touching the mirror? Where does that go?
Stays the same.
Stays the same. Grab a point, reflect it. Grab another point, reflect it. Grab another point and reflect it. Come on, let's do some reflection. Grabbing points and bring them down. Okay. Okay, right. Let's now draw a nice, lovely curve. Okay, that looks beautiful. Right. Are we happy with that, Abdullah? Have you got something like that?
Yep.
Okay, right. Then I think it goes on to part B down here. Okay, lovely. Read this part now for me, please.
The graph of y equals f of x is shown on the grid. The graph G is a translation of the graph of y equals f of x. Write down the equation of graph G.
Take the stuff on, cover it. Okay, let's get back. Sorry about that. Let's just go and close the doors. Right, so that's one of the benefits of working at home. The government says work at home. So you record all the noises of the house in the lessons. Excellent idea, working at home. The graph of y equals f of x is shown on the grid. The graph G is a translation of the graph y equals f of x. Write down the equation of graph G. So this graph has to become this graph. So what did they do to the original graph? So I'm going to highlight the original graph in orange. So tell me, how did the orange graph become the green graph in your own words? What did they do?
They move it across.
They've moved it across from -2 all the way to
4.
So we've got how many jumps have we done?
6.
Fantastic. So what do we call that? We've done a what?
Translation.
Translation, and so it'll be by vector 60. Yeah. So how would you translate that to how would the graphs be manipulated? We say then, so G will be equal to what? G will be equal to f of x. Now remember, if you're moving +6 along the right, so
6.
we're gonna have to think about, oh, sorry, the -6, isn't it?
Yeah.
So it'll be -6 inside the function. Fantastic. Because we're going right and right, we think as positive, it'll be the opposite inside, be -6. And that's how we do. Fantastic. Done. See, not a sine graph, it's just a quadratic graph, is called f of x. Okie dokie. All right, next question. Carry on. Do number 11 for me as well, please. I need to kind of go on. Read.
A sketch of the curve y equals sine x for 0, x 36 is shown below.
Okay, 0. Okay, now that's the range. That's actually saying x is greater than or equal to 0 and x is less than or equal to 360, not 36. 360.
Oh, yeah.
So that's basically telling you there's nothing to be confused about that in the exam. That's just telling you that the graph's been drawn between 0 and between 360. Okay, that's all. So nothing to be called, oh my God, what's that? 0 to 360, what does that mean? Nothing to be fretting about, worrying about in the exam. So So they're giving us a sine function, it's all fully labeled, lovely. Yes, okay, what do we do next?
You need to sketch it. So
what do they want us to do now?
using the sketch above or otherwise find the equation of each of the following two curves.
Beautiful. So this was the original function here. This was the original function. And then that original function became this function. And they're asking you, what did they do to the green one to turn it into the pink one? What did they do?
They move it up.
Moved up by what?
1.
Fantastic. So how do you write it down then? Do you put the 1 inside, outside times what's happening?
You put it outside.
Beautiful. Sine of x plus 1 means you're translating everything up by +1 in the y direction. Fantastic. Now they want you, have they got us any more? Use this way, find the equation of each of the following two curves. I think there's a one missing somewhere. Or it's got photocopied in the wrong place. I think one of my graphs has gone astray. We've lost a part of the question. Sorry about that, folks. Okay, never mind. I think we're starting a new question here. This is okay. Thank you for that, Abdullah. Thank you. Okay, let's have Layla, please. I wonder whether Ikra is your microphone fixed, Ikra? I think she had issues. Yeah, I think she might still have issues as well. Okay, Layla, let's go. Come on.
Okay.
Next question. I'm going to zoom it in for you. Zoom it. Whoa. Come on.
The graph of the function y equals f of x is shown on the grid. The point P minus 1, 5 lies on the curve. On each of the grids, draw the graph of the transformed function. In each case, write down the coordinates of the transformed point P.
Lovely. So the above function, they want you to move it by f of x plus 3. What I would say is, actually see if you can copy it across first. I'm going to see if I can do a little bit of cheating here. Okay, I don't say do that in an exam, but I'm going to grab the graph and I'm going to see if I can copy it. And then, it's gone. What happened to it? Okay, let's try that again. All right, that didn't work. Let's try that again. I'm just going to try to, come on. Excuse me for my pen's glitching a bit. Okay. Copy. Paste. Woohoo! Okay. So that's called proper. Paste. I'm just going to superimpose the original. And paste. Okay, right. So I would advise you in the exam to do a quick little sketch of it and put it into the right place. Hopefully my graph is not too far out. So they want you to do f of x plus 3. What does the plus 3 do if it's inside the graph, Layla?
You move the whole graph left.
So you think of plus 3 as right, but you do the opposite of your intuition. You move it to the left by?
By 3.
So we're doing a translation of the graph by the vector minus 3, 0.
Yes.
Okay?
Yeah.
Okay, lovely. So they really want us to do P, really only. So we go 1, 2, and 3, because each value is 1. So the minus 1, 5 goes to what?
Minus 3, 5.
It will go to minus 1, going back by 3, it will become minus 4. If you look at the...
Oh, yeah, you're adding.
And the height will still be same as?
5.
5. If you want to do it in the vector style, we could do that as well. Minus 1, 5, and then minus 3, 0. That's the translation. And that will give you minus 4.
5.
Minus 4, 5. Give you the same answer. Okay. So really, in a sense, we actually don't need to redraw the graph, but it just helps us to have the graph there so we can physically move stuff around. Next one here. What's the manipulation here?
Okay, y equals 2 f of x. So you're multiplying the whole graph by 2.
Okay, but in which direction?
Upwards.
Stretch.
Yeah, you
by
said
a scale factor of 2. So these points will stay here, this point stay here, this one will go down to here to minus 20, and
So
the
you
minus 1, 5 will go to where?
minus 1.
Minus 1, 10. Yes?
Yeah.
So do you see what we're doing? So we aren't, in a sense, we're not really redrawing the graph, but we are kind of like thinking about where those points are going. And we can, if you want to just draw that part of the graph, you're welcome to do that. That will not harm your, so you could just see, give yourself a little bit of a visual representation. That's gonna go this way, and that's gonna go that way. Okay, you happy with that?
Yes.
Next one at the bottom.
Okay. Y equals minus f of x.
So where's the minus? Outside, inside, where is it?
Outside.
What's the outside mean?
That you reflect it in the x-axis.
And if it was on the inside?
Then it's the y-axis.
Fantastic. So we're going to reflect the graph in the x-axis. So here's the x-axis, there's my mirror. And this point here is going to go from the top to the
bottom.
Yeah, it's going to be reflected. So what's the coordinate of the blob that I put over there?
Is it going to be minus 5?
So
minus 1, minus 5.
minus 1, minus 5. Absolutely. Done. How many marks is that question worth? So it's, I think, is there more to the question? Okay, no, I don't think anymore. Okie dokie. Right, next question. Read question number 1.
Oh, do you want? Okay, yeah. Here is the graph y equals sine x for minus 180 is no larger than x, no larger than 100, minus 180.
Okay, so then normally when I've drawn the graph for you, I've drawn the graph for you like this. I've done 0 to 360.
Yeah.
They've gone from minus 180 to 180, and they have the right to do whichever part of the graph they like. So don't get fixed in your brain. Oh, sir showed us this, so why do we have this? This is a different graph. Oh, I'm confused. Don't get confused. They can give you any section of the graph. Okay.
Yeah.
So that's just the graph that I used in my example for the homework. But for the classwork or exam paper, they could use any part of the graph. They could even use just negative part only, or negative and positive as done here. So don't get yourself fixated on something that you've seen in the homework. Everything must be the same. It doesn't work like that. Okay,
Yeah.
what do they want us to do now?
On the grid above, sketch the graph of y equals sine x, add 2.
So what's the add 2 now doing? The add 2 is outside the function. What does it do to the graph?
You're moving the whole graph upwards.
So you are translating the graph
Upwards by 2.
So 0 along the x, but 2 along the y. We're grabbing the graph and moving all up by 2. So the 0 goes to 2, because 0 add 2 is 2.
Mm-hmm.
This y value here, which is 1, will go to 3. The 0 height here will add 2, will give you 2.
Yeah.
At minus 90, the y value has a value of minus 1. And when you're going to move it up by 2, it will be minus 1 add 2, which will go to plus 1.
Yeah.
0 add 2 will be 2. Okay, and hopefully I've done that right. Let me just try to join it up together. Okay, right, here comes the spinning of the iPad. That's not going to work. Have I done? No, I think I've done. Yeah, that point's wrong. Straight away I realized that. That one point should be a 3 up here. Yeah? Is that right or no?
It's 2.
It should be a 2, isn't it?
Yeah, you add 2.
So was that right the first time? Let's put it back at 2 here. I'll just get rid of that. And the minus 1 goes to plus 1. Okay, and then we have here. Okay, let's have a look. So, oops. Okay. Does that look okay?
Yeah.
Yes. That looks lovely. Okay, hopefully got the points right. Okay, good. And then it says, here's a graph of y equals cos of x from -180 to 180. Now, what do they want to do? On the grid above, sketch the graph of y equals -2 cos x, -2. So we have to draw -2 cos x. What happens when you put a -2 on the outside?
Is it going down? Oh, you're multiplying
We
it by
we got two things happening. We got a 2. What does the 2 do to the cos graph?
it makes it less.
It stretches it.
Oh, yeah, I know.
Yeah, the 0 points here, they stay where they are because when you multiply 0 by 2, it still says as 0. So let's do the first part. Let's just double it first.
Oh, yeah, you multiply by -2.
And then you invert it. No, you don't multiply by -2. I'm doing the question in two parts. I'm doing this part first. I'm doing the stretching part first. And then I'm going to do the inversion in the x-axis. Okay. So then
yeah.
I'm going to change color now. So the part that was up here at +2 will be now at
-2.
and the part which on the mirror, because there's a mirror, on the x-axis. That's what the minus is doing. So they stay there. So let's get back to our red. Okay. And this bit over here, which is at -2, will go to what?
And 2.
+2.
Yeah.
And this bit at minus, so that will go up here as well, +2 over here.
Yeah.
Okay. Okay. Done.
Yeah.
So remember the black graph was the original one, this one here. I'm gonna highlight it for you in green. This is the original graph here in green. So this original graph was first of all turned into the blue graph by doubling everything. Then it was inverted to become the red graph. That's what the minus done. So you got those different things happening there. Okay, right. Question number 2, please.
Okay. The graph of y equals f of x is shown on the grid below. On the grid below, sketch the graph of y equals f of x -2.
So there's a -2 inside the function. What is the effect of the -2 inside the function?
You move it right.
So you think of minus as moving left. So you do the opposite of your intuition. You move it right. So
Yeah.
it is a translation. So it's going to be right. So it'll be 2, 0. So 2 along the x-axis and 0 along the y-axis. So everything is shifting across. So this point goes to there. And this point goes to there. Everything moves across. And this point here moves across by 2 values to here.
Yeah.
So we have a nice little kind of curve here. We have a nice little curve here. Okay. Everything has moved across by +2 along the grid. And 2 is worth 2 boxes. Now this point here is going to go across by 1, 2 over here. This point will go across by 2. It's going to go to over here. So now let's join them up. Okay, lovely. Hopefully everybody's got that. I'm gonna scribble off all the wiggly bits so we don't get confused and I don't confuse myself. Okay, are we happy with that new graph then? Yes?
Yes.
Fantastic. Okay, lovely. Let's look at the bottom one now. What's happening here? So we've done that now. Part B. Let me get rid of that so you can see. Lovely. Read, please.
On the grid, graph A has been reflected to give graph B. The equation of graph A is y equals g of x. Write down the equation of graph B.
So there's graph A for you. I've color coded it for you. So graph B is this one here. This is graph B. So how does graph B come from graph A? What have they done to us? To this question, sorry. No, not what have they done to us.
You're reflecting it in the y-axis.
You reflected it in the y-axis. Okay, so how do we indicate reflection in the y-axis to the so the A is g of x. So our B is going to be what?
G, and then inside the function, minus x.
Okay, done. Fantastic. Okay, I think the answer is supposed to go here. Never mind. It's just the question got slightly offset when I was doing the production. Okay, right. Let's have a look. I think we should do a little stop of the video here.